Let's welcome our three speakers from Pearson Education. Pearson Education is an education technology company that provides training and education material and technologies to schools and corporations. And they have a very interesting presentation today that they implement Marvin and JChem into their online homework and assessment system.
So I'm Jeanne Zalesky. I am the executive editor with the chemistry list with Pearson Education, and I'm joined by our software developer and engineer. This is Seann Ives, and also Loiselle, and she's going to talk with you a little bit about the student experience. So I just wanted to set the framework for what we're going to discuss, and that's the nature of making MarvinSketch a useful tool for students learning organic chemistry as undergraduates. So I'm going to talk a little bit about the context of what it means to use MarvinSketch for undergraduate education, and then Sean's going to talk with you about the details, the technical details of engineering this for education, and Laura's going to talk about how we modified it further through student usability testing to make it an even more accessible tool for undergraduate students. So let me just skip right to the point. So Mastering is a platform that Pearson developed, and it's the most widely used online homework and tutorial tool in the country. As of the end of September, we have 1.6 million science and engineering undergraduates actively using our tool to study and learn their discipline. One of the reasons Mastering is so effective is that it is cross-platform, and so we've developed several different ways to assess students specific to their course area. In organic chemistry, we worked with Marvin to develop a problem type for organic chemistry, obviously. But as you can see, we publish across the sciences and engineering, and our goal is to remediate misunderstandings that students have as science and engineering majors and keep more majors. As you've probably heard, STEM education is in a state of transition in this country, and Mastering plays a significant role in retaining these majors and making sure that they get remediation when and where they need it. Just a little bit about how it works. Mastering was built actually based off of CyberTutor, which was out of MIT. And this was created by a physics professor who was teaching about 300 students a semester, and through his educational research and experience as a teacher, realized that the biggest learning opportunity for students is when they're actually practicing. And not only when they're applying their knowledge to a problem and problem solving, but when they get it wrong. And they have that open mind to say, why did I get that wrong? That's the learning opportunity. And so professors teaching 300 students at a time, and most students do their homework at 11 p.m. or midnight the night before, can't possibly give that individualized coaching to the students when and where they need it. So we've tried to replicate that digitally. And the way that it does so is with answer-specific feedback. So whether it's physics or engineering or biology or what we'll show you in chemistry, our system identifies exactly the nature of the error that the student made. So it's not just canned feedback, you got it wrong, try thinking about this. Our system evaluates the nature of the error, the logic of the error, and tries to give students remediation specific to that. We have a hint structure, so if students don't know where to begin when they're answering a problem, they can access content. This content comes in two different forms. A declarative hint, where it just gives students like a little nugget of information. Remember, 2 + 2 = 4, right? Or a Socratic hint, where it prompts the student to start thinking through the problem and ask them questions and then gives them feedback specific to their answer, even within this hint structure. Then they can go back and answer the problem. The learning gains we've seen in mastering chemistry, and general chemistry, which is why we went into organic, has been significant. This latest efficacy study out of University of Kentucky shows that he had a good control course in general chemistry, same students from one semester to the next, same faculty. The only thing that he changed was the use of mastering chemistry. And he did it again the following year, and we had significant learning gains with respect to fewer drop-fail rates, to a higher percentage of A's and B's in the course. And we're hopeful that this is because of the remediation opportunities that mastering affords. What we've developed with MarvinSketch is the ability for students to enter multi-step reaction mechanisms and basic Lewis structures and other basic chemical structures. And we've developed a system of evaluators that not only tells the student where they made the mistake, as you can kind of see highlighted by this red box, but also through the JChem, you're going to explain the details of how this actually works. But it can tell the students what the reaction mechanism would have resulted in, along with error-specific feedback. So they can learn, just like a professor would, do you see where you made the mistake? Here's what you would have made if this reaction mechanism would have been completed. Do you understand why that's wrong? Try again. And so, Sean, you can explain the magic of how that actually does take place.
Thanks. Good morning. Mastering Organic came from a product from the University of Kentucky, ACE Organic, which is a Java application which is tightly coupled with JChem. It was made by a chem professor there and a CS professor there, and thankfully they still work with us on Mastering Organic. Our job in mastering development was to take the organic chemistry brains out of ACE and put it into the mastering product. And the problem is that mastering is written in Perl, and we needed to be able to integrate the Java classes from ACE and the Java code from ChemAxon. The way we went about this was we piggybacked on the JChem web services that ChemAxon provides. We cracked those open. We made our own endpoint, which incorporated the ACE Java classes, all the ACE evaluation code. And our Perl can then talk to the web services. What we do is we feed the students' submission, their molecule or their structure, along with the packaged XML structure of how a problem is authored up to the web service. The web service iterates through the problem, matching the student submission to each particular evaluation point of the problem. When the student submission matches one of the evaluation points, then we know the student's either correct or wrong, what the appropriate feedback is, and then we send that back to the Perl and back up to the front end MarvinSketch to show the student what's what. Through this, testing was very important for us. We could test the Java web service using JUnit. We did integration testing through Perl from the front end of our mastering application up to the service and back. But one of the important things that we found was we used a free tool called SoapUI, which you can prepackage SOAP envelopes and send them to the web service and get responses back and compare them to what you think is going to be the correct response. And you could use this for any of the JChem web service endpoints, not just the ones that we've created. This was important because we could use SoapUI and their sister tool, LoadUI, to do load testing on our application. We have 25,000 organic chemistry students this fall, going to 65,000 in next year, and we needed to know what kind of hardware to put out there to support this. A lot of numbers up there on the board, but the general notion is that if you evaluate the student quickly, then we can crank through 1 billion of these, just a ton. Once the evaluations start taking a very long time, when the problems are more complicated, the system bogs down. We are throwing hardware at that to rectify the problem right now, but we're looking at cloud deployment to try to mitigate that. And that's generally one of our challenges here. We don't have any organic chemists in our dev team or our QA team. Thankfully, we have some here. The folks at the University of Kentucky were great, and they're very helpful, and ChemAxon has been very helpful with this as well. Keeping up with changes for Pearson enhancements, ACE is an ongoing product, and incorporating those changes and the general ChemAxon changes, those have been our sticking points. But generally, the project is going very well, and we're rolling it out this fall.
Great. So I'm going to talk about what the student experience is like. We built this product. We were so excited to introduce it to organic chemistry, but we needed to understand what that meant for the students who were going to use it. Would they understand how to use it? Would they be confused? Would they know what all the menus, buttons there are? How are they really going to interact with it? So we set up some user testing with students. We recruited 8 students with a variety of chemistry backgrounds. Some had taken organic chemistry, some had only taken general chemistry, some had no chemistry at all. And we did 1-hour sessions with each of the students. We did a little lecture on chemistry so they all had the same background. And then we gave them 2 questions to answer using Marvin. They had to draw structures. This first session was just general, simple skeletal structures, and later we brought them back to do mechanisms with us. And we were trying to see how they interacted. What were the sticking points? What confused them? What didn't they understand? And we discovered quite a few things. Students really struggled with the number of menu options. So we had this kind of full implementation of all the menu options available. And the second they had to go to that file menu, confusion reigned supreme in the room. You know, they were overwhelmed with the number of options they had. They didn't understand what all of them meant. And so they tended to use ones that were completely wrong for what they were working on, or didn't really have any use in the problem they were working. We also discovered there were a lot of buttons and, like I said, menu options that they didn't understand. They didn't know what it was for. It looked like something they thought they recognized, but it really wasn't. So that was a real confusion point for students, and they hadn't even started drawing yet. The next thing was we originally had the tool set up with all of those toolbars with the buttons at the top of the canvas, and students really hated that. They couldn't find the atom buttons. They had a hard time digging through that kind of pile of buttons to find the ones they wanted. So we definitely found some problems there. And then the biggest point, I think, was in their drawing. You know, they were finally ready to start drawing the answers to these questions, and they'd get the carbon atom, and they'd put it on the screen, and they would end up with a CH4, and they didn't know what to do with that. They wanted just a carbon atom. They didn't understand why they were getting something else, and they didn't understand where to go from there. So that took some coaching, but we made it through. And so that was a real important point for us, where, you know, for our drawing, we could just put that carbon down, no questions asked, and keep going, and students stopped. They didn't know where to go, and they didn't know how to make it better to answer the question. Even if they knew the answer, they didn't know where to go from there. So we had to figure out what to do. We had to make this transition from this fantastic industry tool with all of this great functionality and turn it into something that these students understand and can use without stopping them in their tracks while they're working on their homework. So first and foremost, we needed to make sure we were addressing anything that made cheating really easy. That meant we had to remove the save and open options. Let's not make it too easy to save your correct answer and share it with your classmates. We also removed the IUPAC name and the find structure online options because it made it just too easy for students to find the answer without doing any of the work themselves, or find the answer to the next question that might be a follow-up to that first one. We also got rid of some toolbar buttons and menu options that they just didn't seem to understand. The single up and down bond is not used in undergraduate organic chemistry, and they all thought it was the chain bond tool, which it's not, and it didn't work for any of them. So that was a lot of confusion in the room while we were doing some of our testing. So that felt like a button we should remove to avoid just the confusion. And they're never going to use it for our content. The next thing was clear desk. One of the options in authoring our questions is to add a preloaded figure. So we, as an author, could create a question and say, here's a structure, remove this piece, or alter it in some way. And we didn't want students to have the option of deleting the entire figure and then not knowing what they were supposed to do. So that was an option we felt strongly about removing, just to keep things easier for the student, to avoid giving them opportunities to make really big mistakes before they even got going. The next was to rearrange those toolbars and put them around the periphery of that canvas, so it was a lot easier for them to find the buttons they were looking for and to know all the atoms are on the bottom, you know, your toolbar, your template buttons are on the one side. And that was really important for students using the tool effectively. So now that we've adjusted the tool so that they can use it, we've changed a lot of the things that made it hard for them to use, we needed to train them. It took a lot of time for students to get past that CH4, and so it was important that we give them the material they need and the practice that they need to get going with the tool, so they didn't get to homework 1 and spend 3 hours trying to answer the first question because they didn't understand the drawing convention. So we put together some how-to tutorials that have videos on the drawing conventions and a bunch of practice questions that walk students through typical drawing and how that works, and how to draw a chain of atoms, and how to add a different atom if you have just carbons on the screen. And students reviewed that for us. They found it extremely helpful. On redoing the assignments, students were much quicker. They didn't have as many questions, and they were able to answer the questions without as many errors because they understood how the drawing worked. And so that was really important, and it was great feedback for us that creating a training for that and a tutorial that students could work through really made a difference. The next was putting some help documentation together. For those students who still won't do practice problems, even if we beg them to, it was important that we have help available for them to go and find out, oh, I have a CH4, what do I do? How do I get to a CH3? It was important that we have documentation that they could go to. They could click help and get the information that they needed in a quick way. They can search through it and find a specific question if they have one. The next was troubleshooting for Java. As we started giving this to students outside of our first small group, asking more students to evaluate it, we discovered that outside of our kind of canned environment in the office, they were having a lot of Java issues. Their browser wasn't set up to accept it, or they had the wrong browser configuration. And so we needed to come up with a document that detailed all those different scenarios and walked the students through what to do next, how to make it so Java wasn't a problem, wasn't a hurdle, and they could get to work on their actual homework. The next thing, which we're in the process of working on now, is an instructor guide. Something to help instructors understand the grading and presentation settings they should consider using, giving students extra tries on a problem because they may still be struggling with the tool. Maybe they didn't do the tutorial. We can't force it on them. And they've made a mistake. They didn't understand how the drawing worked, and they did it wrong. Making sure that they have an opportunity to ask more questions and get the feedback they need as they're starting to work through those. Giving the instructor a quick and easy access to that Java troubleshooting guide or the help documentation. Making sure they understand what they need to tell their IT departments to make sure their computer labs are set up appropriately to use the tool there. So lots of things we're working on to make this easier for instructors to incorporate in their classroom and then students to actually use it to answer their questions in their homework. We've been very busy helping those students out. So that is the end of our presentation. Questions?
Thank you.
And I understand that Pearson Education is doing mainly student mentoring and tutoring service. As we know, MIT and many universities already put a lot of course online. Mm-hmm. Are you going to put eventually become online course? Provide online course in the future?
Yeah, so the way that mastering works now is primarily homework and tutorial programming. We don't necessarily deliver primary content, so it's kind of that bridge. So MIT courses are primarily broadcast courses. It's a replication of a lecture, but they're kind of lacking this half, right, of interactivity and feedback on your work. And so we are working with our authors and with new authors to create an integrated platform that has primary content being delivered, an opportunity for applying your understanding and testing your understanding, feedback on that, and then we're also pursuing adaptive learning avenues where the system itself can, through complex algorithms and knowledge graphs, actually remediate you with content based on the nature of your wrong answer. So kind of like our tutorial program, but a few steps further with respect to personalizing the learning experience. And yeah, that's actively in development.
Yeah, my question is, I'm from ChemAxon, and could you share these usability study results with us, and maybe with some of these tutorials, so that we can improve the MarvinSketch documentation as well?
Sure.
It may be generally applicable, not just for students, but for the general community.
Yeah, because I've noticed on campus with organic chemistry professors, they are very familiar with ChemDraw. And even though that's like a PC-based, and there's so many reasons why MarvinSketch is better for educational use. But there is, I think anecdotally, about a 90-second learning curve for instructors familiar with ChemDraw as they play around with Marvin. For students, it's more of a, half an hour tutorial. but for professors, even there is some, why do I have to do this and why do I have to do this? So there's good information there, and we can share it.
I just would want to make one comment. I know your system is targeting universities, but I actually think it has more potentials. For example, in the pharmaceutical industry, when we first start a project, and there's like thousands of compounds we can make from modeling or high throughput screening. So what the computational chemistry group will do is they will actually send all the candidates to the chemist and let them vote And they will collect all the results to see which one has the most positive vote, then they will make those first. And sometimes the computational chemists, they will play a practical joke. They will submit the same structure in 2 different orientations, and some chemists actually vote differently on the same structures. But I think with some changes, our system could be a voting system for the pharmaceutical companies.
Yeah,
could be
we
a
do
for
have-
structure or synthetic path.
Yeah, and we do have like a polling functionality that we're working on with mastering, so
Right.
great.
All right, let's thank our speakers again.